In this lesson, I'm going to be talking about adding and subtracting rational expressions. Okay, add or subtract the rational expressions with like denominators. So you just have to remember that your denominators need to be the same value. You don't do anything with the denominators, but you add the numerators. Same thing with subtraction. You just need to remember you subtract the numerators, the denominator has to remain the same. Okay, add or subtract. Okay, so I have my common denominator, and I do 4 plus 16. Well, that's going to be 20b. Now you want to try and simplify. So 20 over 5, each reduces by 5 to get 4b over 3. Okay, add or subtract. Again, these denominators are the same thing. These denominators here, these are the same. So I can just go across and either add or subtract. Now this one's subtraction, so I need to be careful. What I'm going to do is I'm going to do this something of a longer way. Okay, I'm going to distribute my negative through. So then I have 7 minus x, which ends up being a 6x. 9 plus 5. Yeah, that's right. Is a 14 for x minus 3. Now you want to see if you can cancel. So see if there's a GCF in the top that I can cancel out. And I can factor out a 2. Well, there's nothing for me to cancel, but always writing it in that most factored form is helpful, so you can see right away that, hey, there's nothing for me to cancel. Okay. Now these are the same denominator-ish. So if you look at this is 11 minus x, this is x minus 11. See how it's the same number 11, same value x, but they're opposite signs. So if you see that where they're the same exact, just the 11 changes to be negative, the x changes to be positive, all you have to do is multiply one of the two denominators, or one of the two fractions, I should say, by negative 1 over 1. So that gets me negative 3x. And the denominator, that changes that. Negative 1 times x is a negative 11. Negative 1 times 1 times 11 is a negative 11. Negative 1 times a negative x is an x. Now we just combine, and I get negative 8x over x minus 11. And again, nothing can cancel here. Okay, finding least common multiples. Because you know I'm going to give you examples where you don't have common denominators. So we need to get the least common multiple. That's how we get our common denominators. Okay, so let's look at this. So find the prime factorizations of each coefficient. So 12, b to the 4th, c to the 5th. So 12. 12 breaks down into 6 times 2. Then breaks 6 down even more. Well, 6 is 3 times 2. So I have 3 times 2 times 2. Then I have b 4 times. And c 5 times. I wanted to take my shortcut. I can't take my shortcut yet. And then take 32 and break down 32. I'm going to do 32. You know what? I'll do 32 in purple. So 32, I'm going to do it, I'll do it up here. I'll just give myself some room. So 32 is 16 times 2. Then 16, well, that's 8 times 2. 8 is 4 times 2, and 4 is 2 times 2. So this is going to be a little bit of work for us. 32b c squared. Well, 32 is 2, 1, 2, 3, 4, 5 times. 4, 5. And then I have a b and I have a c 2 times. So now your least common multiple. Multiples are always bigger. Use each prime factor with the greatest number of times. The greatest number of times it appears in any of the factorizations. So my LCM here I have 3 once, so 3 has to appear. I have 2, not 2 times, 5 times. Okay, so you always go with the highest number that appear, the highest exponent, essentially. Okay, and then I have b 4 times, but I only have b once here, so I'm going to take b to the 4th. And here, c to the 5th. Okay, so I need to multiply 2 to the 5th times by 3. Well, that's 96, b to the 4th, c to the 5th. Okay, now least common multiple of polynomials. I personally think this is a little bit easier. So what we do is we have x squared minus 3x minus 28. Let's factor that. I need two things that multiply to be a negative 28, but add to be a negative 3. That's minus 7, x plus 4. Then take your other polynomial. And x and x, things that multiply to be a negative 7, I'm sorry, a positive 7, but a negative 8, minus 7, minus 1. Yes, that works. So my least, purple, there we go. So my least common multiple, I have x plus 7 in both of them. It only needs to appear once, but it is part of my multiple. I have an x plus 4, I should say, and then you have your x minus 1. So the least common multiple, the x minus 7, only has to appear once. Even though it's in both of them, only has to appear once. Okay. So adding or subtracting rational expressions with unlike denominators. You want to make sure you have these in your notes. So first, we find the least common denominator. Or, said another way, my least common multiple. That comes out of there. Okay? Write each rational expression as equivalent expression with the LCD in the denominator. So that's why that's so important. We add or subtract the numerators and write the result over the common denominator and then simplify if possible. It is really rare to simplify, just so that you guys know. It's really hard as a math teacher to find ones that simplify, but you always want to see if you can simplify. Okay, so we have this example. Your first step is to find the least common multiple. The first step in that is to factor. Anything that's not factored. So I have x squared minus 6x minus 9. That's x plus 3 squared. I'm sorry, it's x minus 3 squared. X minus 3 times x minus 3. Okay, so let's look at this. What is my LCM? Well, my least common multiple, well, I need to get my denominator so that every single factor appears in there. Meaning, this has an x minus 3, this has an x minus 3. So I don't need to worry about that. This has an x minus 3, but it doesn't have this right term doesn't have a second x minus 3 term. So I need to multiply that in. Remember, you can only multiply by 1. So that's why I disguise that 1 as x minus 3 over x minus 3. So notice how I haven't done anything to the numerator. Of this first term. Now this over here, my common denominator is still x minus 3, but I have to multiply this x plus 3 times by the x minus 3. Again, I don't multiply anything through. In the denominator, I should say. In the numerator, this should be a plus. I'm going to keep messing that up. I need to multiply out this numerator. So first terms together, well, technically that's a difference in two squares. So first terms together, inner terms, outer terms, last term. So I have x squared minus 9. I'm going to continue it up over here, over to the right. So I have x plus 7 plus x squared minus 9 all over my x minus 3, x plus 3. So now I simplify. And this changed. That should remain a minus down there. And then this one over here, let's see if I can just erase that piece. Oh, I can't just erase that piece. This is still an x minus 3. So that's what we get for our answer. Let's do one more, because I know that this is challenging. So we have a y over a y minus 3 minus a 2. Now I factor this. So plus 4 minus 3. Okay, so let's look at this. Let's look and see what we already have. I already have a y minus 3. Each denominator already has that. So you don't need to worry about that, actually. What I need to add in, or really multiply in, is this y minus 4. This denominator has a y minus 4. This one needs 1. So I multiply by y plus 4 over y plus 4. So then I end up with y plus 4 over y plus 4, y minus 3, minus a 2, y plus 4, y minus 3. So then I'm going to distribute. I have a y squared minus a 4y. And I don't think we can. No, there's no way to simplify that top, meaning I can't factor that at all. So this is what our answer is. Okay? Thanks for watching my video on adding and subtracting rational expressions.